In this lesson, we're going to continue to work with our models in RHINO, and by this time they're still architectural models, but we can apply the same techniques, the same tools also for furniture and product design. So I'm going to show you how you can work with various tools to create some oblique lines, curvy cuts and panels, and how we can use like linear geometry, more minimalistic with the mesh, and more curvy with the solid and the sub D right here. So once we define our style, probably is one of these, then we can proceed to divide the element, the general shape into parts, into various parts, and we can distribute them into layers. So this was a shape that we created before using a solid tool, which is the create solid. So when you create like 6 intersecting surfaces like this, then you can create the solid. And this is going to be a closed solid polysurface. So we can start to divide parts out of this by exploding everything. And so once it's exploded, then I can say, okay, this is going to be a curtain wall like this, and this is going to be a wall, and this other back there is going to be another wall, and this is going to be the roof, and this is going to be the pavement. So we define all the various parts. And the gumball usually can be aligned with the object. So we can change the alignment in the command bar. So by typing gumball alignment, or we can press here this little circle, white circle, and you can relocate the gumball, meaning that you can put it anywhere you want, and you can define the X and the epsilon axis and also the Z. Or you can also reset the gumball and put it back where it was originally. Or we can align to the world, meaning the uh, absolute coordinate system, so x, epsilon, z, or align it to the object. You can see in this case, it doesn't make any difference. But in other cases, it will be handy because it's gonna move together with the shape. So let me just, for example, here create a plane. Okay, so if I rotate this, then it's not going to be, you can see it has its own coordinate system. We can call it local coordinate system, like in other software. So if I click here, now this is aligned to the object, but I can align it back to the world, and I can switch anytime. I can also align it to the C plane, which is the construction plane. It's the same of the world. We can align it to the view right now, how we are viewing the object, etc., etc. So let me delete this and continue here. So if we want to reunite everything, let me go back to the standard and use the move. I can put this back where it was with a snap to the endpoints, and then I can select everything and I can join. This will make again a closed polysurface. So you need to be careful whether you're working with a solid, meaning a closed polysurface, or you're working with an open polysurface. This makes the difference in many tools that you have at your disposal. So you have surface tools, solid tools, and then you have specific tools for sub-D and meshes that you can use only with the sub-D and the meshes. So once I have the shape that I want, the overall shape, I can start to separate the parts. I can also continue to model this using the points, the edges, and the faces. I'm going to show you in just a second, and have a more, again, like strange deconstructivist form. So if I don't want to explode everything, because then I need to join back again, I can also use the extraction tool. So if I go back to the solid tools, because this is a solid, there is the extract surface. So I can say, okay, I want to extract this and I want to move it forward. And again, you can see even if I align here to the object, it's going to be an awkward alignment. So you can define it yourself, or you just move it now as it is. Okay, and surely what I want to do is detach the roof and the pavement. So again, I can explode, but this will basically extract all the single surfaces. So as I created here like a seawall with the pavement, I will do it also here. So let's start with these three walls. So I want this to be walls all together. So I'm gonna join them together, and I'm gonna also explain you why. Now, when you have this situation, when you have a poly surface like this, you cannot like simply extrude. If you extrude, the surface is going to, let's say that I select, for example, these three again and press enter, you will see that they will go on one direction. Unfortunately, there is no possibility here to move them. Well, we can do both sides, but this doesn't change the problem. We can change the direction, we can set our custom direction, but wherever we go, you see that they're gonna move in the same direction, which is not really a great result. Now, if I only use the roof, for example, well, yes, in this case, I can extrude the surface and this will work better. So you can see because I'm going only on one direction with one surface. You always need to choose if you want to go one side or the other. If you go downside, well, you will need to fix these corners right here. If you go the other way, probably is better. So let's say 0.3, which is the usual thickness for a roof or a floor. Well, this works better. You can see it's perfectly aligned, even though we will kind of lose this line. You can see it gets straight right here. So depending on what you have in mind, you need to choose the right path. And so to maintain that, let's say line, for example, also here, if I go like this, again, I will have another change in this straight line. So instead, if I join all the walls together with the roof and the pavement, and so let's join, and well, we cannot use extrude. We can use offset. Offset surface is perfect for this because you can see all these arrows, they represent the normals, and all the normals of this extrusion are oriented outward. So if I, again, choose a distance of 0.3, I can flip it inside, but this is going to give me other issues. So again, whether you go inside or outside, you probably need to fix. You can see here this little issue, and but overall it looks fine, and you didn't lose this straight line right here. So if we go the other way, if we go outside when offsetting, and also another important thing when offsetting, choose solid yes. Otherwise, if you don't create a solid, it will create a gap that you will need that to fill with some other tools like a sweep or something. So better to go for the solid already. Okay, so now the problem is that the roof is smaller than the top of the walls here. So we need to model this. We need to either extrude a little piece or move the edges around, but we need to find a solution for that. So every time you do something, essentially, when you start to refining, you need to find fixings and you need to adjust. You need to, solve problems. Here we have this little strange corner that has been created. Not much of an issue, but not beautiful as well. But this is the more important one. So you either like scale and make the roof bigger, or we need to do some adjustments. So what I want to do is extrude a little bit a face here on the side, and I want to push it to the limit. So right here, I'm going to use this point, and there you go. So again, we're going to have this change. Here it's a little bit better, but here it's more visible. And also here we have something to fix. So sometimes we need to extrude a new part like this. Sometimes we can change the position of the edges. So when we work with solids, we can work with points or vertices or control points as they're called, edges, and also faces. We can also move faces. So we need to choose the correct one. And in this case, I would go for the edge. So I want to move this edge, press enter, and I want to move it from that point to this point. And also I'm going to do it here. So select this edge and move it from this point to this point, and